today we will talk a bit about something we did together at Kivra, testing feature interaction in digital payments. And those of you who have seen me before probably have heard about Quviq before, but for those that haven't, I will summarize this a little bit. So property-based testing, or testing with Quviq, is you automatically generate your test cases. Of course, you have to do something for that. You have to write a test case generator, which has some logic in order to spit out test cases. And this is a tool that we came up with years ago and then commercialized in offering services around property-based testing, automatically generating your test cases. So how does it work? You write your test case generator, and then a lot of test cases are spit out. Here we see 2 test cases. You normally write your generator on the level of the API calls that you can make, and if you have a web service, in which is the case at Kivra, you basically do HTTP requests. So it will spit out requests, but it also will know what to expect from the outcome. And then you get a long list of requests, you run those requests, and at a certain moment of time, you have a request which has a failure in it, and the test case fails. And if you have randomly kind of generated lots of requests, then it's normally a lot of rubbish in the requests and in the arguments of the request or the request bodies. So you want to shrink that to a minimum example that you can actually look at and say, okay, this is why there is a failure. And Quviq will then shrink this automatically for you to a minimal counterexample saying, this is actually the error in your code. This technique is not, it is similar to what some people call fuzzing, but it's slightly more guided random generation. So you have random endpoints that you call with random data in it, but the data is not fully random because then you don't get anywhere, right? If you just hammer a system, you will never get very far into the system's logic. So we steer the tests towards something interesting in your software and then hammer it from there on. That's what it is. And then the result is that you may end up with tests that no human would ever come up with, which are bizarre from a testing point of view, but then they shrink to something to say, this is a test case I could have written, and actually it's showing that the system is wrong. So that's the whole idea. Now this idea is not new. It's from 2006 that we started the company, but the idea itself came up from research at Chalmers University in Gothenburg in 2000. So it's this kind of history, and we have been rolling this out at lots and lots of different companies in all kind of sectors. And it's always funny if you come from telecom and you go to the banking industry and say, oh, but this is not going to work for us because we are so different from telecom. And then you go to the car industry and say, oh, no, this is not going to work for us because we are so different from telecom and banking industry. And you go to the railway industry and say, no, this is not going to work for us because it's so different. But now we're back at the financial sector and web services, and it's so different, but it did work for us. Yeah. So let's go on.
Right. So first about Kivra, I think most people in Sweden are probably familiar with the service, but for those of you who don't, it's kind of summarized, it's a digital mailbox. So instead of sending letters on paper, you send them digitally, so you can send a PDF to a person and you can read it on your phone. And it's the biggest digital mailbox in Sweden with 6.2 million users out of 10 million inhabitants or something, so pretty good market share. 2.7 billion things have been sent in Kivra, and we have more than 50,000 companies sending letters, salary slips, invoices, and whatnot. And every month, almost like 4 million users of these 6 million users will receive about 10 million payable content. So this can be invoices or donation requests or loans that you need to pay back and things like that. And out of those content, about 70% of those are actually then paid in Kivra. So it's a pretty big service. We handle a lot of traffic, a lot of critical things, and people pay their rents and stuff using this service. So it's kind of a nice central thing to provide to people, and it kind of has to work. So therefore, working on quality obviously is important. So in Kivra, we have a microservice called Cashier, and that is the service that handles all the payments inside Kivra. And this takes payments requests from clients. So we have Android, iOS, and web, where people can log in, they can view their mailbox, and they can decide that they want to pay an invoice that they got, for example. And then this service will take that request and do some sanity checks, some security things, and it will talk to payment processors which execute the actual transfer of money for us. So you can pay using a bank account. In Sweden, we have a service called Swish, where you can pay to a phone number, so you can use that. And also, recently we introduced automatic payments, which we're rolling out. And this means that instead of logging in every month and paying all your invoices, you can just set them to pay as soon as you receive them. And in order to do all this service keeps a database of all payment attempts, the status of those attempts, and tries to like synchronize this with all the processors and all the user requests and everything like this. So this is kind of the system that we wanted to test in this effort. And we wanted to focus on this new automatic payments feature to make sure that that worked. By the way, if you want to work on this stuff, we're hiring, so feel free to apply for Erlang jobs at jobs.kivra.dev. And we're hiring for this from my team as well, so please apply if you're interested. So the testing goal is, first of all, I mean, we do testing, obviously, as most people in the software industry is doing. But we wanted to try a different technique to improve quality and to validate the system. And the result, I mean, Thomas told you earlier how you write a model specification of your test, and then you generate test cases from that. Our main goal with working together was, for us at least, to get a kind of test report of things that we found, and also to like shore up our static test suites with findings from this automated methodology. Of course, we also have the model, so we can continue working on that. But for us, the most important thing was the quality report that we got. And finding problems or like issues should then, of course, be new tests in static test suites, so that you don't have the same problem again later down the line. And we also want to test like weird usage of the API, so like off the happy path things, like what happens if you send a broken parameter here, or what if you leave out this other notification request from a service and then you try to do something after that. So yeah, lots of interesting edge cases to hit. And inside Kivra, we have a project called Kivra in a Box, which is basically a large set of Docker containers that simulate like a Kivra microservice setup, the way we actually host it in production, but you can run it on your laptop. And this is the setup we use to test. So for every test case that we generate and execute, we run it against this Kivra in a Box. And we could even instrument it so that you would like wipe the slate clean before and after each test, so that you have like a fresh boot of the whole microservice infrastructure, and then you can just run a fresh test case and see how it would behave. And we then test against endpoints that any app could use, so the open API spec that we had. So the idea was like, could a client actually do this? And if so, can we break or find faults in the system which clients theoretically could trigger? And then just try to like randomize these things from a property that we defined. And so we have a big API specification, of course, for this service and for other services inside Kivra. And tests should be generated from this specification in the sense that, for example, if you have, let's take some simple example. You can upload an invoice to Kivra as a sender, and then a user can check their inbox, what's in it. And if they see one invoice, they can attempt to pay it. And if they then list payments for this invoice, they should see one payment, right? So we need to build a model of what the system can and should do, and at what parts, in which part of the system things make sense. And we're trying to find discrepancies between the specification and the implementation. So if the implementation says, in this place you can do this, and then you should expect that response, we might actually run a test case, and that's not true. And then we need to figure out, okay, is the system broken, or is the specification maybe broken? Because maybe you should not be able to do that actually when you think about it. So sometimes you find bugs in the actual spec as well, and not in the code. So we need to know what state the system is in. what can you do with the system at that point? And when you did that, what is a valid response? And if the response happened in the way we wanted it to, what is this new state of the system after that? And then you can, of course, loop this, so you keep doing this, and transition the system through various states and try to find interesting states that are probably not valid. So in this particular example, like Thomas will go into the whole model and how we looked at this from a testing point of view, but some background information is that these payments are, the automatic payments are based on mandates. So when you pay manually, like an invoice that you do it on your phone, and there is an electronic ID signing that you have to do. And then, of course, we know that you are you, and you were there, and you wanted to do this. But if we need to pay an invoice automatically on behalf of the user, we need a mandate from the user. So they need to sign a mandate ahead of time. And then every month when you get an invoice, we can then execute a bank transfer on behalf of the user. And these mandates are then requested by the client when you set up this feature, and then we store them in a database and use them towards the payment processors to actually have the right to do these things automatically.
Yeah.
So back to you.
Thanks, Adam. Yeah, I can take that. So what Adam showed here was one feature. Mandates is a feature of the system. You can set up a mandate, you can do that. And the whole talk will be a little bit about different features interacting with each other and how you can test that kind of thing. So Adam showed you the OpenAPI specification. OpenAPI specification gives you a very nice syntactic way of sending a request and what kind of response you expect, but it doesn't tell you at all how the system should behave. In what order do you want those API calls to be made, right? That is missing in OpenAPI itself. That's not part of the standard. So you need something extra. And there are a message sequence charts for those that are my age, and other people have user diagrams and use cases and that kind of stuff to specify what is happening. And in Kivra, we found this kind of nice pictures of state machines of what should be happening with a mandate. And typically, when you create a mandate, you are connected to some kind of trustly, and then you have to approve the mandate, and then when you have approved it, it can turn into active. It can also fail to approve it because your bank ID was not valid anymore, or whatever reason, then you failed to approve the mandate. But you can go to active, and then you can cancel it any time in this process. So that's the kind of reasoning behind it. So you have to then, as a tester, to combine this picture with the OpenAPI specification and come to some kind of more structured way of writing this down. And this is what we then generate from Quviq. If we have combined this, we basically have a tester which talks to the system under test. So you do your request to the system under test. And in this case, we have a mock for the mandates of Trustly. Trustly is an organization, and you send it requests, and then it checks with banks certain things. And those things, as Adam told me, can take days, hours, months. No, not really months, but Trustly is not kind of a real-time responder. Moreover, if you start giving mandates to empty your bank account, it's probably good to mock that instead of doing it for real. That's the kind of things you want to do. And so there's a mock written by the mock expert in the airline community, Adam. If you have seen Mac before, which was mentioned in the Go talk this morning, Adam wrote Mac. So we are in good hands there. So he created this mock environment for the system. And what happens if I send a mandate request, it's created. I get the created ID back to the system with the tests, which forwarded it back to the tester. And now the trick is to talk to the mock. So I can update the state of the mock. So one of the things you start doing is you explore this a little bit. You create something, and then you say, oh, okay, let's send an approved. I do a next state, and now it's approved. And then you send a notify. You ask the mock to send a notify. The mock sends a notification to the system and the test. So the system and the test must now understand that the mandate is approved, and then you say, okay, next state, the next state is active, and then you get back, you send the notify, and then at the end, the system now should know that we have an active mandate. And from there on, you continue doing the test. This is the happy path testing. This is what you want to see in most cases, that you have a mandate and now you can start doing your payments. But the interesting thing here is that you can also do other things. You can, for example, take the cancel path. And that's a normal, also happy path where the user cancels while making the mandate. It just says, okay, cancel back to the normal state. But what is different then is that you can introduce fault injections. You can now say, okay, what if Trustly is then moved to failed and you get the notification of that the system now is in cancelled and in failed. And you see that there is no arrow from cancelled to failed. So you should there, after doing this fault injection, you should on the front side also see some behavior. What you definitely don't want to see is that the system now believes that you're still in failed, or the system thinks that nothing has happened. You are not even cancelled. So you really want to kind of model that as well. Other things you can do in the case of approved and active is, okay, we send this notification, and the notification is then sent back. Well, we ask Trustly to send the notification. Notification sent back to the system on the test. You can say, well, what if that message goes bzoo? It just gone. You drop a message in flight. This never appears there. And then the next thing that the system and the test sees is that it gets an active update. So you don't see the approved update, but you do see the active update. And then you check, is this ever possible? And the answer was, yes, this is possible. We have seen this behavior from Trustly in the field. So this can actually happen. So we better test that it's well taken care of. Turned out it was not well taken care of, but now it is well taken care of. So you can actually have an approved mandate which is never notified, and then you activate it, and then the system will still work as if it was an activated mandate. And the last, so when you do all these things and you make hundreds and hundreds of those tests through the mandate tree and see, well, this will happen then and this will happen then, and you get it right, then you can start after that doing regression testing. So you use the same model to test whatever happens. And one thing that is nice then is if it changes, you can start reporting that. So I came back after the Christmas holiday and someone had been very active and there was a new arrow popping up. At this moment, you could go from active to failed, although the model said you can never do that because there was no such error. But it worked, and the system would just go through. So then you can start reporting that. Oh, someone changed the code. This was on purpose because it happens to be that this also happens now and then, that Trustly, after sending an active, also sent a failed notification. So this is okay to happen, but it was not in the model, and therefore it was reported and detected. You can also see the consequences of this when you translate it back to the specification, because what you see now is that failed and cancelled have the same input and output errors. Well, basically input errors, because they have no output errors. And that means that they are actually the same state, just a different name. And then you can start discussing, well, do you really have two states here, or is that just an artifact of how you call the thing? But it's actually only the stop state there. So that's the thing you do when you have your model in place. You can start reporting those kind of things. So this you have to do for all the specification elements that you find. So in this case, we had the OpenAPI specification. We have a specification of how the mock works, so you have to connect that as well. But you also have your specification of paying with Trustly, paying with Tink, paying with Swish somewhere, the invoice flow, etc. So all those things you put into the model. And all those things are different features. So paying with Tink and Trustly are two different features of the system. You build that into one model and you run test cases. So what happens then is you get feature interaction, because you have your tests for Tink and you have your mandates and your automatic payments on the mandates. So you start testing things like paying with both Trustly and Tink simultaneously. Oh, you start your mandate. Oh, you start paying manually, then your mandate is activated, and you do something else manually, you actually have paid it already, and then you try to do your automatic payment. What is happening? A lot of that behavior was not specified at all. So a lot of time there was spent in me asking questions to the team, say, well, what do you want to happen here? Because no one really had thought very carefully about those kind of cases. What happens if you remove a mandate while Trustly has an automatic payment in progress? What should happen? All those kind of questions, if you get the test cases in front of you and the test case fails because you have chosen in your implementation for something, then you have to have that discussion, and that discussion then gives you more specification. So this is where you have this feature interactions automatically tested because you have the separate parts in place. And this is, I think, the strength of using this kind of test generation methodology, because you only have to write a linear model for each feature. So each feature has a number of lines of code in that model. But by generating test cases which explore all kinds of features interactively or interspersed, you get a lot of benefits. So think of the mandate that I showed you on the first slides. If you wanted to write a few good tests for a mandate, you would do the positive test case. You create a mandate, you approve it, and it's active. That's your one test case. Another test case would be the cancel test case that I showed you. If you are kind of curious, then you also want to go from active to cancelled in another test case or in the same test case. But you want to write 3 or 4 test cases for mandates. You want to write 3 or 4 test cases for an automatic payment going through all the way, stopping halfway. You want the think payment to go through all the way, halfway, etc. So 3 or 4 test cases per feature would not be very weird, right? That means if you have a system like Kivra has, with at least 20 features, many more than that, you would have to write 80 test cases. And then you have a reasonable coverage. And the other thing that you have to do is whenever you have another feature then that you want to add to the system, you only have to write 4 more test cases. And that's a doable amount of work. But we know that the errors that you will see are in the feature interaction. If you have 2 features, that a pair of features that you want to test. So you want to test creating a mandate and paying by Think at the same time, paying by Trustly and paying by Think at the same time. That's the interesting test cases. That's what you want to test. If you manually are going to write those tests, and you have 1 test case for each feature that you have in your software, you have to write another 190 tests on top of the test you already wrote. Now, you will, as a developer, say, well, some of those we don't really need because I can see that they do not interfere, and that's fine. But basically, you have to write a whole lot of more test cases to do that. And this is also why, if you're on a software project and you see this burden of every new feature that you add is more work, it's because you have to add 20 test cases for your 21st feature, at least to cover the combination of that new feature with all the old features. So if you feel this like we're going slower and slower and slower, the more features we add, totally normal, it's because the way you test. And what you really want to test is triple of features, right? And then things explode, because then you have to write so many tests that no one in the world is going to do that manually, right? The only way out here is this test case generation that I talked about. You have to automatically generate your tests in order to find all those feature interactions and how things work. And that's what Quviq actually is doing for you. So to conclude, because we're there, our findings of this project, it was a 3-month concentrated kind of project where we just did this. I just did that. Adam was doing his normal work and answered all my questions. We did get a lot of tricky test cases automatically generated. That was the whole idea, and we got there. We also learned that specification consists of many different parts, and that it was value to join them in one big model. That was opening the eyes of, okay, this is how it should work. Negative tests were, of course, not run so many before. So in the negative testing area, we found a lot of kind of smaller cases that we then could fix. Like this dropping the Trustly notification to cashier. That's one of the examples where a negative test case shows you that you have forgotten something in the system. We also found some from unknown issues which could be tested, fixed as well. So some things that actually showed up in this testing which were not known to be bugs at all. That was it. Questions?
Thank you for your talks. I think we have time for maybe one question. Any questions? Okay.
I have a question about the OpenAPI standard, is there any initiative to kind of overcome the limitation of not being able to specify a state machine?
Yes, there's two things that I recently read. One is called flow diagrams, and they put that into the OpenAPI specification, and that's basically describing some kind of user stories in a more detailed way, which is a bit clumsy, but still good in the right direction. The clumsiness is in the fact that it is only by example, and you really want the specification. And then there's something called Azura, which also tries to solve that with message sequence charge-like specifications, but that is something I don't know the details about.
Thank you. If you have more questions, we have in the break because we are running out of time. Yes.
Thank you.
Thank you.
Thank you.